Hi, everyone. Welcome to the AWS User Groups of Florida Virtual Edition. So a few quick updates about our user group. As many of you know, we've been operating virtual for the past 18 months now. Hard to believe. Things look better. We'll look to do more of a localized regional format, but glad to have everyone here with us tonight. We'll get to the topic in just a moment, but please do engage and collaborate with us after the meetup. If anyone would like to present, provide ideas for topics or formats, we're all ears. After tonight, we'll post the presentation and the recording to SlideShare and YouTube, and update the meetup post with those URLs. Throughout next month and this month, feel free to engage with us through our Slack team. For tonight's format, you are muted by default. Feel free to unmute yourself if you have any questions, or type those questions in the chime window. As you can see, Piyush is getting the conversation started. We'll leave time for a dedicated Q&A at the end. And please feel free to complete our survey. This provides great feedback to the team on content, and they'll be pasting that link in a moment. So tonight we'll talk about applications of time series data with the Amazon Timestream database. I'll let Piyush and Andres introduce themselves here in a moment, but really excited about this one. A lot of power and I think a long anticipated service. Quick note, we try to have these meetups about once a month. About to schedule next month, which we'll talk about Amazon Connect. That'll be November 16th. So with that said, I will hand it over to you, Piyush, to get us started.
Sure. Hello, everyone. Nice to meet you all virtually. I remember doing this in Miami face-to-face a couple of years ago, but then there was a break, for obvious reasons. And good to see you, see everyone at least virtually now. Hopefully, we'll get together soon physically in Miami one time. But my name is Piyush Bothra. I'm with AWS for about 3 years now. I'm solutions architect with AWS, and I specialize in Timestream, Amazon Timestream database. And today, our agenda is we'll just quickly go through very high level what Amazon Timestream database is, what is its value proposition. And then after a few slides, I have my partner here, my partner in crime for this presentation, Andreas Jiffinger, who is all the way from Austria joining us. Andreas, you want to introduce yourself?
Yeah, hello. Nice greetings from Austria, the country of Sound of Music. Maybe you know what that is. My name is Andreas Joffinger. I am also a solutions architect with AWS. I'm not as long as Piyush with AWS. I'm 2 years now, 1.5 years with AWS, and I'm also specializing on time series data. And that's why I'm quite glad to have the opportunity to talk to you today and show you a little bit of demo of what we can do with Timestream.
Okay. Awesome. Thank you, Andreas. All right, so let's get started. Let me start sharing my screen. And meanwhile, feel free to, kind of unmute yourself if you have any questions in between, but we'll leave some few minutes towards the end of the presentation for you to be able to ask questions. And feel free to interact in chat as well meanwhile if you have any questions, and one of us will be able to answer that. I'm trying to find, okay, screen. All right. Do you see my screen, everyone, or?
We do, yes.
And okay, all right. So what I'm going to do is I'm going to also turn off my video while I'm presenting because that's not important at all. Okay. Okay, so Amazon Timestream, it's a purpose-built time series database. It was released fairly recently. It's almost a year now, actually a little more than a year. September 2020 was when it went GA, and we are almost a little more than 1 year. And it is purpose-built database for time series data. Now let's talk about what time series data is, because some of you might be familiar, some of you, and I'm sure many of you have used it already, but how is it different from any other type of data? Why do we need a purpose-built database for time series data? So time series data is a sequence of data points recorded over a time interval. What does that mean? So any data or any measurement or metrics that changes over time is basically time series data. So in other words, time series data is a sequence of data points recorded over a time interval. A few examples would be, let's say, stock price, right? So when you go to a stock tracker and go to any stock and want to track the price of that, maybe last 1 year, 5 years, it will show you the graph, right? So basically what you're doing is you are analyzing this price of that stock over time, right? So that stock price is measured over time and you are trying to analyze it. That's what time series data is. Another example would be, let's say there is an industry sensor, right, which is emitting temperature or pressure metrics on regular interval, and you want to track those measurements so that if there is any anomaly in the measurement, let's say if a temperature goes very high, above 80 degrees or so, or the trend starts shifting, then you can get an alert or something like that. So you want to monitor temperature of a device, right? So that would be another example of a time series data. So with time series data, each data point consists of a timestamp. That is the rule basically, right? So if each measurement should have a timestamp associated with it, and you can have more attributes associated with it, which we'll talk about a little bit more, which kind of provides metadata to that measurements, right? So for example, if you're getting the sensor data or reading the temperature measurement from a device, then device ID could be a metadata, right? And then location of the device could be another attribute, and then so on. So basically, time series data is the data which measures how things change over time. So I showed you a couple of examples of where time series data is used. Now let's talk about some of the use cases, right? Like you might have already guessed, right? So some of the use cases would be industrial productivity, right? Where you want to monitor machines metrics or sensors metrics to make sure that industry products or industry machinery are performing to the level they are supposed to, and you can maybe detect any anomaly in the trend and identify a failure before it happens, right? Same way with predicting the energy demand and looking at the historical data and predict future values, right? Because how a stock market has many of the stock market analysis and technical evaluation that do on stock market is based on the historical performance of the stock markets, right? And seasonal trends and those kind of things. So many times you can use historical data to predict future values. So time series data analysis is very powerful there as well. So it helps you in forecasting capacity utilization, right? And to help you make supply chain decisions based on that. So if you have, you can basically track the the supply and demand the situations with time, and then have additional dimensions associated with it, like seasons, right, or time of the year, and that way you can do some good predictions based on the historical analysis. These are some of the use cases where time series data is utilized. Now, okay, fine. So we now understand what time series data is and what are some of the use cases where you use time series data. But then why do we need a different database for time series data? Why can't we use a traditional relational databases for that? Now, you might have already imagined that the nature of time series data is basically to where you track the change in a measure based on time, right? So what that means is that data is getting ingested every moment, sometimes milliseconds, microseconds, in seconds, and constantly getting ingested from all these devices and sensors and IoT devices. And if you're using it for financial stock analysis, then every minute of the stock price. What that means is that any database which stores that data has to scale in huge, got to have some very good scalability when it comes to storage, right? Any traditional database or relational database you would need to add more and more machines and more storage as your storage grows, which kind of becomes very difficult to manage many times, and also sometimes becomes not practical. So many of our customers would complain that, hey, with our existing solution, we have to get rid of historical data because we just cannot keep with the volume of the data which comes in. And so that's one problem that managed time series database solves, where it provides you that scalability. And the Timestream database kind of provides virtually, there's no limit on amount of data you can store in Timestream database. The second aspect is data management issues with rigid schema, right? So any relational database would require you to define the schema beforehand. However, if you look at the nature of the time series data, let's say you have thousands of sensors out there in the industry which are emitting the data, and you're storing those data. Now you have a new set of sensors which is giving you another new measurement, right? So if you have predefined a schema, then you'll need to do a lot of changes to incorporate a new measurement. However, with a purpose-built time series database like Timestream, it is schema free. You don't need to define a schema beforehand. And then we talked about storage scalability, but then there is performance as well. Let's say if you're able to manage this storage and you are able to scale this storage to petabytes of data as it is required by time series database. Usually the existing solutions would not keep where the performance will not be able to keep up with the volume. So as your storage grows, your performance will start declining. That's what usually we have seen, our customer has seen with the existing solution. And all this, even if you're able to achieve, then you will need to, kind of do a lot of undifferentiated heavy lifting to manage the servers and manage the indexes to, keep the performance up to the level. So a lot of management work will be involved there. So these were the challenges with the traditional database when it comes to time series data, which we were trying to address when Timestream database was launched. So Amazon Timestream is completely serverless. There's no server to manage, no software patches, no indexing you need to do to tweak the performances. All these are done automatically for you. It performs at scale. So even if your data volume goes from terabytes to petabytes, right, performance is not compromised as much. And you get two tiers of storage with Timestream database. One is in-memory tier and another is magnetic tier. So you want to keep your hot data in in-memory tier where you want to do very point in time and narrow queries. However, for your analytics or big data kind of queries where you want to extract months and months of data, you can life cycle the data to magnetic tier, right? And both the tiers perform very well for specific use cases. And it's secure from ground up. Security is number one priority in AWS. So data at rest and data in transit, both are secured and you don't have any other option. So they are encrypted at rest and in transit. And you have an option to use customer managed keys with KMS for that. So that's the value proposition of Amazon Timestream, and we will dive a little bit deep into this. So again, it's serverless, right? So any new feature releases we do, like any other managed service with Amazon or with AWS, you don't need to worry about updating the software. Now let's look at this picture a little bit. Now I talked about scalability, I talked about storage, right? But how does it happen? What is the magic behind it? So it's like looking under the hood of how Timestream database is designed. So if you see here in this picture, the storage layer, the ingestion layer, and query layer, they are three separate components of the architecture, and all three scale independently. So as your storage layer increases, and as your storage increases, right, your storage would scale independent of your compute or your ingestion layer and query layer. Now, if you have, let's say, for example, huge volume of writes coming in, right, and your ingestion is very high in volume, that would not impact your query. So at the same time, if you are querying the database, there's no performance impact to your query layer because they both scale independently of each other, and they are decoupled from architecture point of view. And so that's how Timestream takes care of scalability and performance aspects. It provides 4 nines availability SLA, and then one important thing is the query when you query the data in Timestream database, you use standard SQL, which so you don't need to learn any new language, or if you know SQL, then you're good to go, and you can use just standard MC SQL to write your queries. It scales to petabytes of data and beyond. There is no limit. And magnetic store, there are two tiers that I mentioned, right? So magnetic tier is designed to perform well for analytics kind of query, and in-memory tier is designed to perform for point-in-time narrow query. Now, one important aspect here is that as you are define your life cycle of data from in-memory tier to magnetic tier. Now, magnetic tier obviously is cheaper in price, so storage is cheaper there. Now, if you write a query, at the query time, you don't need to know where your data reside. So let's say, for example, you have got the historical data and you want to life cycle the data after 3 months from in-memory tier to magnetic tier. In that case, and if you write a query to get last 6 months of data, you won't need to know that, okay, only latest 3 months data is in in-memory tier and other data is in magnetic tier. Timestream does the job for you. You write single query, and Timestream has adaptive query engine. It tracks where your data resides, and it will give the results to you. So completely managed data lifecycle, completely simplified query patterns, which knows where to get the data from. Now let's quickly go into some what are some terminologies of Timestream database tables. So like I mentioned, it's 100% managed database service. So all you need to do is create your database, create the tables, and add lifecycle policies on when you want to move your data from in-memory tier to magnetic tier. That's all. And then define your data model. That's all. You won't need to do anything else when you start using Timestream database. Now, each row in Timestream database is called record, right? And you don't need to define the schema up front. In-memory tier storage can range from 1 hour to 1 year, right? Maximum. And you can set your lifecycle policies to move the data to magnetic tier. And you can keep the data in magnetic tier for virtually multiple lifespans. That's cool. And then let me skip through some of these slides so that I want to show you a slide where it will make, okay, yeah. So let's look at this. How data in Timestream database is stored, or how will it look like, right? So this is the table in Timestream database. And this is a use case example where, let's say you are using Amazon EC2, AWS EC2 instances, multiple servers on AWS, and it's a DevOps use case where you want to track CPU utilization and memory utilization of your instances, right? And so your EC2 instances start ingesting the data into Timestream database, and for each timestamp, as you can see in this table, you have dimensions, what we call your attributes of the data are dimensions. So you have VPC, what VPC that EC2 instance belong to, region, US East 1, right? Availability zone, and then what you're measuring. You're measuring CPU utilization. So that becomes your measure name, and then associated value for that measure. So that's how Timestream table, or these are all terminologies of Timestream table. One is, of course, you'll need timestamp, each record. Then there are something called dimensions, which are region, VPC, host name, availability zone in this example, which you can call as a metadata associated with your measures. And then you have what you're measuring. You're measuring CPU utilization. So your measure name becomes CPU utilization. And then if you scroll down a little bit, you'll see memory utilization as another measure. And then there are values associated with those measurements. So this is how the data would look like in a Timestream database. There are multiple data types that Timestream supports, which is in our public page. Double, big int, varchar are some of the data types. Boolean is another data type. Okay, so now we talked about Timestream terminologies. How do you get the data in Timestream, right? So, okay, you already use Timestream database. How do you get the data in Timestream? Now, if you're familiar with other Amazon AWS services, so Timestream database provides you 3 ways to work with the database. One is you can use AWS command line interface, CLI. Second is it provides SDKs, which SDKs in multiple languages like Python, Java, and then a few other languages which Timestream supports. So you can write your code in those SDKs to interact with Timestream databases. And you can use endpoints, Timestream endpoints to invoke APIs and do the job and ingest your data that way. But if you're using other Amazon AWS web services, for different use cases, you can use different services. For example, if you have analytics use case, right, and if you're using some of these streaming services like Kafka or Kinesis, then you can use Apache Flink, which has an adapter to push the data directly into Timestream, Amazon Timestream. So this would be one reference architecture for that use case. And then on the right-hand side, if you see in this picture, you can integrate Timestream with some of the BI tools like Amazon QuickSight, and then you can also integrate with if you want to do machine learning, which is a very, very common practice to do machine learning on top of time series data, right? So you can integrate easily with Amazon SageMaker, which is our machine learning service or platform, which provides the capability to design models and run your machine learning models. And then you can visualize your data in Grafana as well. We have Grafana managed service. And if not, you can build your custom, if you want to build your custom visualization tool, or you want to integrate it with your website, then it provides JDBC connection as well to query the data from Timestream. These are some other use cases, IoT devices, so it integrates with AWS IoT Core as well. So AWS IoT Core, you can directly ingest the data in Amazon Timestream for IoT use cases. And for DevOps kind of use cases, we have integration with open source tools like Telegraph and Prometheus to collect the data into Timestream database. And then again, on the right side, as you see, you can further integrate with the tools like QuickSight and SageMaker and Grafana. Timestream cost, pricing can be divided into three areas. One is, of course, the storage cost. Another is how much of write that you do. And third is query. And query costs will depend on how much of the data is scanned by your query. So we always recommend our customers to use write filters in their query to get the data, only the data that they want, to minimize the cost there. But storage cost is very low for magnetic tier. As of today, it's very close to what S3 standard pricing is, which is our S3 or storage service. All right, with that, I'll stop this slide deck. I'm sure you're all waiting for the real demo or real work. And I'll hand it over to Andreas to go through the demo.
Okay, that's excellent. Thank you, Piyush. If there are no further questions, I think there was one from Prakash. You might actually also see now exactly how that integration with SageMaker Notebooks works. Just give me a second.
Yeah, I'll post,
starting to share screen.
Yeah, sure.
So, Piyush, give me a quick shout out if you see my screen.
Yep, I do see your screen.
I've zoomed in a little bit, and just to briefly explain what I'm doing here is I have used SageMaker Studio, and fired up a number of Jupyter notebooks or SageMaker notebooks because I think it's a quite easy way to demonstrate things. And I can have here also some markups and explanations. And I can also then basically in the end of the demonstration, I can export it as a PDF document, and we'll be able to share that with you. And here also as an add-on to the question of Prakash, you already see how we actually use it within the notebooks. Basically, we use the Boto3 SDK, Python SDK, and there are a few sample Python documents or Python scripts which just do a few things of parsing the query and the result set and so on. All these things are available on GitHub. I can also send you then the link on that. But first, what I wanted to show here on this demo is how easy it is to actually fire up a new database and creating a few tables in there. And for that, I have opened now in the Amazon console, the management console, the Timestream service. I can click here on Create Database, basically select Standard Database, and then choose my name, Meetup Manual, for instance. As Piyush mentioned before, Amazon Timestream is always encrypting data at rest. So it is important here to choose my master key. In this case, I take the Amazon managed master key. Commonly, you should take your data at least with an owner. I'm doing that, and maybe you can also add some cost center, I don't know, to the tag so that it becomes easier for doing the billing later on. And that's it. We have a new Timestream database. If you want to see what's going on here, we basically already fire or provide you some monitoring insights here. Of course, there is a quite deep integration with CloudWatch also, but here you will see some initial overview of how healthy the database is. On the Tables tab, you then can create a table. And now here I can choose my table name, call it my table. And this is the important part, what Piyush also mentioned before from the architectural slide, where you have these two tiers. And you can choose here how much data you want to keep in memory or how long you want to keep the data in memory. And a rule of thumb here is you always need to think about how late might some data come, or how old might be data which I want to upsert. And that's a usual, I take here 24 hours, basically 1 day. And on the magnetic store retention, I have also to choose some value, and I usually take 5 years. That gives me a reasonable amount of time to actually look into the data and so on. Again, tagging same thing as usual, having an owner tag and maybe some cost center or project so that billing becomes easier in the end. So now I can create a table, and bottom line, that's it. Now you have created a new database in Timestream with one table. This table has an in-memory tier of 1 day memory store retention and a magnetic store retention of 5 years. You see it has just been created, and you also see now basically the time, what it is here in Austria, because we're coming close to midnight. And you can then already query the data, and in the query editor, choose the database, what you want, choose the table, click on preview data, and it's quite simple. And then you can fire the first query into an empty table. So basically, exactly what we expected to happen is that we get 0 records back. So much to that, so much to the manual steps. But what I also wanted to show you is how you can do that in the Python language with the Python SDK. I have to initialize here a few things. So I choose the region, profile, and I define here also a new table and a new database, because I also want to create a new database on the fly. I initialize the SDK and the client according to standard behavior of the Python library. Here, you might ignore the first one. I'm just usually cleaning up. And if I click now here, then I can just run that script, and it will create me a new database with called Meetup Demo and a new table with DevOps data. Going again back into the database, I can now list the databases here. I have now here the Meetup demo. It's just been created. Yeah, 938. So Meetup demo. Sorry. I have here a table, DevOps data. I can query it, and again, I have a memory store retention of 1 year and a magnetic of 5 years, and that's exactly what I have defined here as the retention properties when I was creating the table. So much. The table is again expected to be empty, but what I wanted to show here is some kind of simple queries, what you can use, and here is also again the link to GitHub, where you can find these tools, that ingester tool, but also the other integrations into SageMaker. where I'm taking that timestamp query Python script from, which I'm using here in the background, so that the handling of the queries is a little bit easier in the notebooks. I just start that now, and you see the query. I get a query ID. The describing shows, well, there are no columns, there's no schema so far, there are no attributes, no dimensions, no measure names, and the count basically shows also there is no record in there. I'm now using, again, out of that GitHub project, the continuous ingestion tool, which is here under Tools, Continuous Ingestion. It's this one here. And start creating some records. And I can just click on this and run that Python script, and it will start creating records for me. While I'm doing this, I can copy that query from here, go again back into the query editor, and have a look on what's going on. So you see I'm already having 2,500 records in there. Just waiting a few seconds, 3,000, and so on and so forth. So what does that continuous ingestion do? Like it says here, it basically creates standard metrics for computers, like CPU, user, I/O, and other things, mostly random variables. We'll see that in a minute. For a quite big fleet or for many potential microservices across multiple regions, across multiple availability zones. Although I have parameterized it here for only one region and a host scale of 1, so there's not many instances created for this. Now I need to interrupt that so I can see what's going on. And again, I'm just can fire that describe query, which is a specific read query, which allows me and gives me back basically the identified columns. Some of them, or most of them, are dimensions. You see that here also. Some of them are measure names and some of them are measure values. Yeah, and of course time is the timestamp. Yeah, so like Pierre said, each record has to have a timestamp. It has to have a measure name and a measure value, and can have a number of dimensions so that I can easier work with it in that sense. And I see here I have about 8,000 records in there. And then it is already at the point where it's okay, well, I have a Timestream database table and I can fire standard SQL queries. And I think most of you have worked anywhere in your career with SQL before. The only difference here in this query is that it's recommended to always have the time literal in there in the work clause, so that you say, okay, which aspect of time you're interested. But other than that, it's a standard query, what you would see with also a standard SQL database. So the dialect of SQL is quite close to the normal. So what I've done, you will see here, so I have create for some of the CPU measures, trying to figure out for the microservice Apollo, how many different values I have here, just figuring out that there are only 33 time points for that measure. And the next thing what I can do is now to really dive a little bit deeper into these tables and get me some data. And here, you see again the time. I've just created that about 10 minutes ago, 4 minutes ago. The measure name is CPU user. I have a measure value of a double here, which is 66.63%. And the dimensions, microservice Apollo in the availability zone, central 1.1 in a silo on this instance running. Well, that's pretty much it, what I wanted to show here. And of course, using the different things of Jupyter Notebook or here of Python, I actually can fire additional queries and then quite seamlessly plot that stuff. And as you can see, that was the data what was ingested. I have here two different time series. The one is the CPU user, which is between 65 and 100% here. And the other one here is the bytes, network bytes out as recorded. And it's kind of fluctuating between 5 kilobytes per second and basically 0. Yeah? So much to this. Are there any questions at that point? I don't see any in the chat. Then I will quickly go into the next, a little bit more interesting queries I've prepared here. Basically, I actually did start that ingester tool already a bit earlier this evening, so about 3-4 hours ago. And just to show it to you, I again need to initialize that, and let's have a look what we have in that. It's the same ingester tool, so we have the same dimensions, times, and measure values here. But the difference here, I have now already a meaningful number of records. So I have here about 1.5 million records in there. On which I can now do a few different operations. Again, the first thing, I'm just looking into the data for the last 10 minutes. Simple, standard SQL query. I'm limiting it to 30 just to overload don't overload the notebook here. But in the end, I want to look into the data of the last 10 minutes. It's still running, so let's see. And here again, it's conceptually basically the same data what we saw before. And I'm creating two different ways here. So and I'm going to visualize that. Yeah. And like you can see here, you might say, okay, well, that has a kind of upwards trend here. And if you see that kind of data, or if you see that kind of visually through visual analytics, you can kind of see that that's going a little bit up. And it's not completely fair because I knew that's going to be a bit upwards trendy. There's a question in the chat. Sorry. So Piyush, you mentioned Patrick. I'll look into that in a minute because it's a bit a question. And yeah. And what I've done here is, and this is now showing really a bit more the power of the SQL dialect of Timestream. Well, I'm doing a bit weird things though, but if you look into this query, I'm copying that out here and going into the query editor because then it's easier to read. Should I move in a bit more? What I'm doing here. So Timestream provides you with kind of time functions and aggregate functions, and binning is one of them. So I say, okay, well, I want to bin the time on a 3 minutes interval. So the time will be always binned to the closest 3-minute interval. And I want to get the geometric mean of the CPU user measurement value. And I then, of course, have to group by these values, similar like in other SQL dialects. And if I run that query, then I get 1 point for every 3 minutes if it works. What's here? At line 1.1. Maybe I think. Should it be this line? Did it work before? That can be because I'm copying it around. I keep it. This one worked here. I need to look into why it's not working on the query editor. Anyway, but I can now load the data, and now you surprise, you will see here I have binned the data on 3 minutes interval, but I've also binned it on a 15 minutes interval. So that you will see, okay, yeah, I have a very clear SAW signal, and that's exactly what I would have expected here. So if you use the time series just like here, you might be on the finite granularity, not so easy to see these things, but with time series functions, you quite quickly can figure out what's going on in the data. Are there some kind of underlying trends? What's behind the data? What level of granularity is relevant for my application or to visualize it? Visualizing is also another point, and you quite often see that, and I think I did also show that here. The values of CPU usage are, of course, between 0 and 100%, but network bytes out are somewhere between 0 and potentially several millions or megabytes. So it would be quite difficult to visualize both of them into one graph, and I've just put that here. And if you see that, you see now, okay, in one graph, you wouldn't see any difference, and you will completely lose the trend, or you wouldn't see the trend and the values of the CPU usage. So what I would do here is to actually, now you can use some common table expressions, and I'm doing again the same query as above. But now I'm also calculating the min and the max value, and then I'm normalizing the data and project it onto the interval of 0 to 1. And for everybody who is interested in that kind of stuff, it's quite common to do that in time series operations or time series machine learning and that kind of stuff. It's called the min-max normalization. So what is the result of it? It's basically, the result is that I normalized both signals or both time series into the interval 0, 1, and now it's much easier to visualize them into one chart. And now you can maybe also see that here a little bit better is I have both values are between 0 and 1. Of course, you would need to remember how you did normalize, and you can then label the graph effectively. But you see the network and the CPU usage is now in the same number range. And for those of you who are interested in time series machine learning and that kind of stuff, it's also quite important to do normalizing the data of them for time series algorithms. So there's one last query what I wanted to show also, because I think this is also quite often coming up. Sorry. That is windowing functions. Of course, when we are talking about temporal data, we often want to see the average of that data over a certain period of time, or over a certain number of preceding and following measurements. And that's exactly what I did with this query here. And again, it's just straightforward. You just craft a query. It's a bit a learning curve for all the extensions, what Timestream provides to standard SQL. But in the end, it should be quite simple. And again, if I look into the CPU signal here, and if I do have a running average, then I see also very clearly here that upwards trend of my data. And you might actually be able to extrapolate that and say, okay, well, in about an hour, I'm running into a problem, or in about 5 minutes, I'm running into serious problems on that machine. Better use that for a scale out event, and therefore bring the data or the effort down, or the CPU load down of the fleet of instances which is running. And if you use it that way, I think it should work. If I haven't messed up too much here, just to copy that query directly into the query editor. Yeah, now so this is there was something wrong with the other query before. So again, like I mentioned, so and that's also one of the nice things with time series and query crafting is you can use the same queries in your machine learning load. You can use your queries in your applications. You can use your queries and reuse the same queries in your business intelligence tools like Tableau or whatever, or QuickSight, and then you're more than happy to you will get consistent results across multiple tools because you're basically pushing that load and that complexity of queries down to the Timestream database. That brings me to the end of the demo. I think we have a few minutes left for questions. I will stop sharing screen and go on video. And I'm trying to catch up. Piyush, were there some questions which I might help to answer in the chat or?
No, there are none so far. And yeah, any questions, feel free to unmute yourself and let us know. Just wanted to add a couple of references here. We have many companies, many customers who are using Timestream database to this petabytes of a scale to analyze millions and trillions of record. Our own Disney is using Timestream, Amazon Timestream database. So if you look, Disney Plus actually, so Disney Plus videos uses Timestream database to analyze the video quality with respect to time to provide better video quality services to customers. So that's one very good example. And then we have many other IoT customers as well.
Piyush, that's actually a question. Maybe you can talk a little bit about some customer use cases we can take a look at. Should I open the homepage?
Yeah, please.
While I'm doing that, I'm trying to answer also the other question, which how to productize these charts. It really depends on your technology. We provide the AWS SDK for Timestream, like Piyush mentioned before, in .NET, Java, Python, even Node.js. So whatever technology or whatever programming language your teams are used to. And then it comes down to using a visualization or a charting library, because that charts what I'm using here, that's just very simple NumPy, which is a standard library in Python. But you can use basically every visualization, whatever you want or what you're already familiar with. And as I said, these images have been created.
Yeah, just to add to that, so Prakash, if you're looking for visualization tools, right? So Timestream integrates seamlessly with Amazon QuickSight as well, on top of what Andreas has said. So Amazon QuickSight is a BI, AWS BI tool which integrates with Timestream. And then if you want to use many of our customers, Grafana is a very widely used open source tool to dashboard time series data, especially in DevOps and other scenarios. So we have you can use Grafana as well to visualize the data and look at all those charts and everything.
Yeah, maybe I misunderstood a little bit the question. If you want to work with individual charts, these things are maybe too heavy and too much functionality in there. Although you can use QuickSight individual charts and embed them in your application. So this is definitely one of our recommended way. Nevertheless, if you have a kind of suite dashboards and so on, then you really very well recommended to use Grafana, the managed Grafana, what we have on Amazon, but also QuickSight. And from the customer stories, of course, I think I'm sharing my screen. Piyush mentioned before already Disney. what I can talk a little bit about is we see Timestream very much used in different IoT scenarios, and be it Tensor, sorry. So, be it Tensor IoT or any of the other IoT companies, where a fleet of many hundred thousands of devices are out there, are actually sending MQTT data or JSON data over MQTT to Amazon, and then we persist the data. You can do that directly over IoT Core rules into Timestream. You can also use Kinesis, and I think Piyush mentioned it also before, and has had it also on one of his drawings, using Kinesis and the Lambda function to push the data into Timestream. And these are the ways where we support very heavily quick and large-scale streaming applications. As I said, personally, I know most about that IoT field, where maybe individual diggers out there in the world are producing engine data, and that engine data is then sent over IoT into Timestream, and then people can do fleet monitoring, fleet management, seeing how many hours of the data actually the engine is running. What's the percentage on the daily run? Is it 8 hours? Is it 12 hours or whatever? And it's that kind of things what we see directly done on Timestream. But of course, if you want to do kind of predictive maintenance and that kind of stuff, then you would need additional algorithmic, and maybe you want to use SageMaker here. I hope that answers the question. Are there any other questions? I'm trying to find the chat. Herbert, any other specific topics you wanted to talk about? Maybe just put it into, thank you. Okay. Prakash, I think we've also done there. The Disney story is also it's a nice video to watch. I think there's a video even to watch.
Okay.
And yep.
All right, then.
I would love to say to everybody and repeat that there is also a survey. Maybe you can find that link now just in there. It takes you 30 seconds, and it's quite helpful for us to improve over time, and to make sure that the things we discussed today are of value for you. Please, I shared just the link. Give us feedback, Piyush and myself, that we know. Other than I think I'll go back to Patrick. Do you want to make some closing words?
Of course, yeah. No, thank you so much, Piyush and Andreas, especially since it's past midnight now.
Yes.
This has been, for me, this has certainly been informative. I myself was very excited to hear about first the announcement of Timestream, and then the long anticipated GA of it. I see a variety of use cases in kind of the operational field, and looking forward to getting my hands dirty with it. So, thanks again to both of you for presenting, and thanks to the community for joining us tonight.
Thank you for giving the opportunity, and very nice to our pleasure to present here, and hope to see you all again.
Likewise. Thanks,
Thank
guys.
You.
Okay.
Good night, everyone. Thank you.
Bye.